Hey guys, today I want to talk about the MPCForces-Extractor. That's a tool I have been programming for the last couple of weeks. And yeah, I did some live streams about it, but there have been some really significant updates recently, which I did not cover in any live stream, and I just wanted to share that with you. And if you have not seen the live stream, that doesn't matter. I will quickly motivate this tool. So why is this? If we are here on the GitHub page, it tells you that it is a tool about get forces from RB2s in OptiStruct summed by connected parts. Now, I have also read me a little bit, and yeah, just imagine something like this. You have a RBE element or MPC element which constrains nodes together. Just say you don't have any idea how many and which parts those MPCs connect. The goal of this tool is now to sum up the forces, but on each side, so that you can see or judge how many forces transferred from one part to the other. All right. So this is basically the idea of the tool, and why this is even a thing is I did not find any comfortable way of doing that in the standard HyperMesh Hyperview tools. So let's just say you have something like a model. This is a simple model to just demonstrate that. Maybe quickly I can show you something why this is even a thing. Why would you want to do this? Let's just say you have something, and we will cover this model later. Something which has a lot of those MPC constraints. And those MPC constraints, I should say, elements. Those MPC elements, they model bolts or screws, right? And it's a modeling technique which is pretty simple but also very effective. So there's no context here. You have no 3D bolt or 1D bolt with stiffness and stuff like that, properties, or any other elements which connects two parts with stiffness properties, but it's just a rigid element. A very simple approach, but yeah, you would want to have an idea how much loaded your bolts are if you model it like this. And if you have 100 or 200 bolts in a model, you don't want to do this. In the following process, I would like to show you how it would be done in HyperMesh Hyperview. Now, let's say you have something like this. This is a model, pretty simple. You have two load steps. One is pulling, one is pushing, like in this direction. You can see it on the screen, right? You have this one RBE2 element which connects the two parts together, and the part is constrained to not move here. Now, if you have something like the MPC forces output, which you can check here in the output section of the load step, then you have an output for those forces which are transferred here. Let me quickly show that to you, what this looks like. Let me just open that. Yeah, so you can write it to a file which looks like this. So this is the exact file which belongs to this model, right? So you have subcase 1, you have also subcase 2, and for each of any node which is connected to an RBE, I think. Well, here's the point. I'm not really even sure if that's the thing. Let me phrase it differently. I'm pretty sure it's not like that. It's not outputting all the nodes which are connected to a SPC. Just if it has a significant force, then it's getting outputted. Right, but yeah. This thing aside, this is just a text file which can be outputted. The other way is you can also write it to the H3D file, and then you have it accessible here as a vector plot or contour plot. You see then there's MPC force. And if you apply that, you have like colors and see that. Now, vector plot gives you a little bit better of an idea, right? But the thing I was really struggling with is there's no easy way to just detect the connected parts and group them, right? You can define sets. That would be a thing. Yeah, but let me just show you the process, right? So you're here. Let's say I want to have all the upper nodes, right? So that would be Okay, I need to go to table. Then here, let me clear the table because I did that before. Now I have to check the vector MPC forces, because if I don't have the vector, I have absolute forces. And absolute forces, that sums up to something which is not really significant. So vector MPC forces has to be checked. Now I have to select the nodes, and I could do that by line, by whatever, by face, or yeah, multiple different tools. Let's just say I would do something like pretty simplistic, like this, knowing that I select more than I should, but it's also right. Then I press apply here, right? There's a lot of nodes which are just 0, 0, 0. But there should also be, yeah, there should also be some valid ones. Now, I copy that. I go into my favorite tool of all time, irony, Excel. I copy that here. I paste it. I do some separation. Now, this is X, Y, Z. Now I go here to the bottom. Well, basically, it's good thing that it's sorted, right? So you could also just have it go until you don't have something here. It might not be, right? So don't take my word for that. There could be something down here. Depends on the node numbering. Yeah, but okay. So I have something like this, and then I would go here and do the sum of all that. And you see here that I have 500 newtons and 0 in the other direction, which is that what I would also think I should get, because this was, I think, subcase 1, either one. It's just transferring 500 newtons over this connection from loading point to constraint point. Okay, so that makes sense, but just pay in mind, this is one RBE 2 element, this is one subcase. So it's a little bit of a pain. Now, let me quickly talk you through the tool, how I would do that with my tool. So you see that the quick start tells you to just pip install the MPCForces-Extractor, which would take the latest version and install it onto your system. There's also more documentation here, which we go into in a minute. And then you can just use this by just typing in MPCForces-Extractor, which then will open up something we will see in a minute. Now, the documentation, if you just wanted to have more documentation, you see also there's different versions already. So for all those guys who were in the live streams, 0.1.0, that's the tool we developed together in the live stream. It was basically a CLI tool. So if I just go here into the quick start, you see that if I do that, then I get like a CLI tool where I see I have the extract and visualize command, and then I have to give in some paths to model files, and then it will do its thing and write out a text file. This was basically the way it worked. But now things have changed. And I'd like to demonstrate that to you in a minute. For me, I don't have to install it because I'm already having that installed. So for me, I can just simply go in here and type MPCForces-Extractor. And that should open my app. So it takes a minute. Now, this is a little web server which serves as input and also output of that. It has a light mode, a dark mode. It's not too fancy. It's also not too optimized. I'm not really fond in JavaScript and HTML, but I took on the challenge and I'm quite happy with the result, to be honest. Okay, so basically you can run your tool here in two ways. The first way is to give in the source files. That would be the upper part until this blue button. We will cover both ways. And the other way is to import a database. So you must know that for each run this tool will do, it will write out a database file. That's because if you have a huge model, it might take several minutes and you don't want to have to run it again. Because one part of this algorithm is that it can detect, if you have this red MPC, what is part 1 and what is part 2. So it does a part segmentation algorithm, graph-based, which is pretty awesome, I think, but takes time, right? And also, just imagine I have to deal sometimes with gigabyte big files, text files, .fem files. And just reading that in takes minutes. So basically, and I've not tested that in too much detail, but we will see later on a model with 200k nodes, 200k elements. And this runs in around 20 seconds or so. So it's decent from speed-wise, but it's for sure not perfect. All right, so 2 ways, right? The source files would be the FEM file and the MPCF file, and the database would be the other way. We will see both ways. So let's start with the simple source files way. Now I will do the same model I showed you, which is the one with 2 ls. It takes a while because of my network drives. Yeah. Now let's do the MPCF, and also notice that there's this file selector. So if you have misspelled, for example, the file extension, it would not display it to you. And here also the ls file. And if you have a command window open, you can see what it does there. For me, I have to go here and see in the console window what this tool is doing. And now if I run the MPCForces-Extractor, I see the logs here, right? It takes no time because it's a small model. But from the point I pressed here, there's also a little note here which success extractor runs successfully. Yeah, it's pretty minimalistic. But from now on, you can also go into the MPCs and the nodes view. Let me explain that to you. So the MPCs, that's a list of all MPCs it found. So if you have 80 RB2 elements, it would have a list here of 80 RBE elements. This is the element ID. This is the node ID of the master node. And then you have several buttons here. So all slave nodes can be copied, right? So for example, if I would want to see where this is, I could go here and say nodes by ID, because I copied that right now, and just paste my clipboard here in. And you can see then that all the nodes are, all the slave nodes, I should say, all are then being selected, right? Okay. Now, what else do we have? We have part ID to nodes. So here the part segmentation algorithm took place, and I have part 1 and part 2. If I would have more than 2 parts, then it would be a list of several parts here. But here is 2 parts, and if I just copy one of those, yeah, I can just do the same thing again. Sorry. Yeah, and now for sure I will have just 1/2 of the nodes here. Yeah, pretty cool, huh? Sorry. Well, my voice is not there. All right. So this is that. And then we have the extracted forces, which tells you for each subcase and each part which amount of force is transferred. Note that there is no direction information given here. Maybe that's something to add later, but yeah, I'm fighting with space. Yeah, so this is one thing, yeah. You have the 500 newtons, which are seen in both subcases and both parts. And then you have the nodes view. The nodes view is a view which shows all the nodes which have force data on it. So all the nodes which are appearing in the MPC forces file. And there's also a pagination here. Oh, excuse me. There's a pagination here, so if you have more than 100 nodes, which we will have in a future model, then you can go previous indexed. But basically what you can do here is also filter the node by the node IDs. And if I just paste the nodes here in, I will just have those nodes, which is one part. And here I can see where those nodes are, so X, Y, Z global coordinates. And also can see the force absolute for each node and the moment absolute. Still, there's no information about direction. That's maybe a point for the future. And subcase can also be selected from 1 to 2. I have to see if you have to. Yeah, you have to do something to upload it, to refresh that. Yeah. I think that I should add. Yeah, so basically that's it. Now, let's see a little bit more complicated models, right? I have prepared 2 of them. So this is a model which is also like a test model, right? So, but here you have also strange hobbies elements which just connect to nodes, right? Where the master node is part of one part, so to speak. Now let's see how this goes. I will go back to the main page and select model. Oh, sorry, that was the wrong. Okay, so that was the M-many model. Okay, let's add that. Okay, let's run it and check the NPCs. So here you can see that you have a bunch of them. Yeah, you get the idea, right? So you can see all the different RBE elements with the slave nodes, the parts, segmentations, and also the forces. Yeah, here it's just a dummy force, so there's nothing really transferred. Just a little bit of, yeah, something. Okay, now let's see a bigger model. We have the model I promised with the 200k elements. I think elements. Yeah, 200k elements. And we will run that through and see how the time is performing. But basically, it should be alright. So even if you have a 1 million nodes or 1 million elements, it should run in several minutes, not hours. But for sure, it can be improved. Now, let me run that for you. That would be the flange 4x4. That would be that one. And it's also interesting what takes the most amount of time. So I have learned that the read-in takes a lot of time. Because, yeah, it can be big text files. Yeah, so let's run it, and I will switch over to the console window. So we started the run, and I also included some timings in the log file so that you can see. But this is all reading in the FEM file, right? It's just I/O. Reading. Yeah, then it does the segmentation and stuff, calculating connected components. That's the second bigger part. But you can see 5.9 seconds for the segmentation and 12 seconds for the reading of the FEM file. I would say that's still okay for 200k elements. So I think it's usable. It's for sure not perfect, but yeah. Okay, so we have run that. Now let's check that. So basically, what do we have here? 4 models, just copied, with each 3 RBE2 elements and just different loading conditions. There's nothing with contactors, so it's just a simple model to do that. And just imagine if you would have to calculate the amount of force which is transferred by each bolt. The operation, the funny one with the Excel thing here, I would have to do that 4 times 3, so 12 times. For each subcase. Now imagine I would have 16 subcases. It's not so fun. Okay, so we run that already, so we can go into the NPCs, and you see here we have the 12 different RBEs with also connected parts. Oh, that's interesting. Ha ha ha. Alright, I think I have to do some debugging here. It always lists all parts. Normally it should just have the parts which it connected to. Yeah, well, yeah. Okay, so there's a thing which I might have to take a look at. And also here we have something like this. This would be a RBE element which is just connected to one part, right? This one. But you can copy that and see which is that. So let's do that. Then by ID, and you see it already, it's where the forces is attached to. And that's also what I think is pretty cool about this tool. It works pretty well in combination with HyperWorks. Because you have now here the sets more or less already in place. You don't have to really do that manually. So this is pretty cool. Yeah. All right, so I think, yeah, that's about it. So basically that's the state of the art. Code-wise, I will have to do some improvements. I will just fondle around and improve that over the time. But if I see that the people are using that tool over GitHub or so, then I also will not delete the versions, because just see about how I did go with the versions. There's 0.1.0, that was the first CLI, and then I did a bunch of things until I have something like a somewhat better release, which is usable, I would say, right? It also has a dark mode. Yeah, sorry, I'm being nerdy, but yeah, I really like that, and it was a good journey until now. And yeah, we'll continue to do that for sure. It's given me great pleasure and great fun to do that. And yeah, so if you want to know something a little bit more about software development, because I learned a lot about here too, for sure you can also ask something like this. So this also uses, for example, automated workflows, which does all the publishing. And so, I mean, it's an open GitHub. You can just look into it and see it. And yeah, with that, thank you for watching. If there's anything I can help you with, also with the tool, if you find a bug, please tell me. Yeah, shoot me a message, open an issue here. Yeah, just help me to make this even better. And if you have a use case, something which also could be solved by a lean tool, something like this, yeah, reach out to me. I would be happy to just see what else I could do to make this a little bit better. All right. Thank you guys for watching, and I'll see you in the next one. Bye, guys.